Hello, sixth graders. We're going to talk you through the answers for this review assignment that was for ratios, unit rates, and percents. And we'll start out with this first problem. It was about pet collars, right? And wanted to know which one you were getting the better by. So we talked about that. A lot of these skills that we're learning dealing with rates, unit rates, proportions, percents, they're helping us understand comparisons or predictions. And so here we wanted to compare the prices at Pet Palace, Dog Digs, Happy Pets, and Just Dogs to find out where we'd be getting the best value for our money. So what we did here is I took the rate that they gave us. In this case, it was a package of 40 for $94.79 at Pet Palace. And I just divided that out to find the unit rate. So we think back to when we were finding our unit rate, all we were doing is dividing this top number by the bottom number. I put the dollars on top and the collars on bottom. So I did $94.79 divided by 40 collars would tell me how much I'm paying per one collar. And you could definitely find the cost the other way. You could find out like how many collars you could get per $1 or something of that way if you would flip the fraction. But typically when we're looking at cost analysis, we deal in the amount per unit. For example, the cost per pound or per ounce of food or per t-shirt, how much are we paying? In this case, we're talking about per collar. So I just did that same division problem across the board here. And then I saw, to answer the question here, which store is offering the better value, I saw that Happy Pet was offering the best value because the cost per one collar is less than the cost per one collar at any other store. And that cost, again, was $1.98 per one collar at Happy Pet. So if you were going to buy however many collars you needed, depending on the packages that were available at each store, you would want to try to buy your collars at Happy Pet to get them for the best price, the best value. Number 2 on this one, we had Angela's unit rate. She enjoys swimming and at a steady pace to burn calories. She can swim 1,700 meters in 40 minutes. So it asks her unit rate again. So I just put her 1,700 meters over her 40 minutes, which is a rate. But then to find the unit rate, we just divided that out. And I set it up here in this one, again, kind of like a fraction, just like up here. Because you could just think of it that way as we're simplifying the fraction to get a denominator of 1. If I did 40 divided by 40, I'd have 1 minute on the bottom, and 1,700 meters divided by 40, I'd have 42.5 meters on top. So that's how I end up with this 42.5 or 42.5 meters per 1 minute. And then it asks, what does that rate represent? Well, in this case, it kind of represents an average. If she were going to be swimming for 40 minutes and we picked out any one of those minutes, we could expect that in that minute she would have swam about 42.5 meters. And that's what I tried to explain here with the answer to 2B. That takes us to number 3. Alejandra's driving from Michigan to Colorado to visit a friend. Assume she drove the speed limit the entire way, which was 70 miles an hour. If their combined driving time for the whole trip was 14 hours, how many miles did Alejandra drive? Well, that rate in this case is 70 miles per 1 hour that we're assuming she traveled the whole time. And we know that she went 14 hours. So in this case, I kind of did equivalent fractions in the other direction. We're using the unit rate with a 1 on the bottom here to project this out, to make a prediction. And so 1 times 14, because it was 14 hours, would give me 14 on the bottom here. So I'd also have to take 70 times 14. And in this one, this makes a lot of sense just to think it through, right? If she's going 70 miles an hour for 14 hours, we just have to multiply that out. Again, it'd be like if you bought 10 t-shirts for $15 each. How much did you pay? Well, we had to pay $10 or $15 per shirt, and we bought 10 of them. Same kind of thing here. We drove for 70 miles. We drove for 14 hours at 70 miles for each one of those hours. And I wrote a little explanation of that on there too. You can check that out. This next one, Mary took a road trip to her grandmother's house. She drove the constant speed of 60 miles per hour for 2 hours. Then she took a break and finished the rest of the trip driving at a constant speed of 30 miles per hour for a third of an hour. What is the total distance of Mary's trip? And use a model to explain your reasoning. So this one, at first you might be like, well, why would she, stop? This actually kind of makes sense. If you were going a great distance, this first 60 miles per 2 hours could be the entire time like on the freeway, and then when she'd stop to take a break, maybe the rest of the trip, which was a third of an hour, so only about 20 minutes, or not about, it is 20 minutes, she could have been like on side streets or in a city where she couldn't go so fast, right? So the model that I drew was just a simple line, like here's the start of her trip, you see here, and then that leads to her break, and then she picked up the trip again here. But then to make this a model, I wrote the rates on the top of this line, and then the distance that I calculated below. So in this first part of the trip where she went 60 miles per hour for 2 hours, it's very similar to what we saw in number 3 with Alejandra. We just need to take 60 times 2, because for each one of those 2 hours she went 60 miles. So we take 60 times 2, and we know that she drove 120 miles in that first part of the trip. That was a much easier part. Over here they give us a fraction. And I go, okay, a third of an hour, and you start scratching your head a little bit. But think about it this way. How many, if she went 30 miles per hour for that third of an hour, how far would she have gone if she went the full hour? And that's something to think about, to help you kind of, I guess, multiply this out, right? So I took this rate of 30 miles per 1 hour. I put the 30 miles on top and the 1 hour on the bottom. And I said she only went that for a third of an hour. So instead of times 1, or like we did over here, times 2 for 2 hours, I did times 1/3. And so then I cross-canceled this fraction here. I divided out a 3 of both the 30. I was left with a 10. And of the 3, I have a 1. 10 times 1 is 10. 1 times 1 is 1. So 10 over 1. She went 10 miles. Now take that answer and think about that. If she went 10 miles in a third of an hour, well, when we go the full hour, 10 plus 10 plus 10 would give you back to the 30 miles for the whole hour, right? So 10 miles in a third of an hour, or 20 minutes. If she went the full hour, she would have gone 3 times that far, right, to get to the full hour, which would be 30 miles per hour. So back to the question, to answer our question, I take the 120 miles of the first 2 hours, and the 10 miles that was the time after the break, and I get a total of 130 miles. All right, so we're going to pick it up here with number 5, which is a problem that dealt with percents, fractions, and decimals here, and some conversions between them. 100 offices need to be painted, which is great for us because percents deal with parts per 100, so it made these conversions really easy. The workers choose between yellow, blue, or beige paint. Complete the table to show each value as a percent, fraction, and decimal. Use the 10 by 10 grid to create a model that shows the percent of offices will be painted each color. So on this table, they give us different parts for each color that are filled in. And on like the yellow, they filled in first for us the percent at 45%. And remember, percent per century for 100. 45% is really easy to convert to hundredths as a decimal. So we could take 45%, which means 45 out of 100, and change that into 45 hundredths. So basically just sliding that decimal point 2 places, right? Or if I wanted to write as a fraction, 45% means 45 out of 100, so I write 45 100ths. And then we typically reduce those fractions, put them in the simplest form. And so if you had 45 100ths, that's a pretty good start. That's a good understanding of creating a fraction from a percent, but taking that to the next level would be simplifying that fraction, putting it in simplest form. So I took 45 and divided it by 5, and 100 and divided by 5, and I got 9/20. That was the greatest common factor, was 5 I could divide out. And then for the blue here, they gave us a fraction of 7/25, which, to turn into a decimal, you could just type that in your calculator. 7 divided by 25. Remember, every fraction is a division problem in disguise, and you could just divide that out. This one has a nice denominator for us, so that's easy to convert to hundredths. So I just actually multiplied it by the top and bottom by 4, did 25 times 4 to get 100 here, and then 7 times 4 to get 28. And now that one's sitting as 28 hundredths, which I could just write as that decimal as well. Don't even have to go to my calculator. And then 28 hundredths, or 28 out of 100, is 28%, so I could fill in the percent box as well. For the beige, they gave us 0.27 or 27 hundredths, which again, if I just read that out loud, 27 hundredths using place value, I could write that as a fraction as well, 27 over 100. Lucky for us on this one, it's already in simplest form. They don't share any other common factors besides 1. And then I'll put it as a percent as well, 27%. You could either just slide that decimal 2 off of your decimal version, or you could think about it here from fraction. 27 out of 100 is 27%. Okay, and then to color these in, again, your shading doesn't have to match mine exactly. I know some students I already saw had shaded them horizontally instead of vertically, or maybe you stack these 3 blues down here or something. Or I mean, you could make some kind of fancy pattern so long as you have 45 of them shaded yellow and 28 of them shaded blue and 27 of them shaded beige. And then wrapping up this video here with 6, 7, and 8, dealing with percent problems. On 2 of these, I thought it would be really helpful to use a double number line. 15% of an amount is 30. Calculate the whole amount. So what a double number line does, in this case, is going to list the percents on one end, on one side, top or bottom, and then the actual number on the other. And then we try to create an equivalent ratio, which is, proportional relationship, to find the missing value. So if we know that 15% of an amount is 30, I'm going to model 15% on the top of the line here, 0, here's 15%, and the end of my line then would represent 100%. And I know that 15% is the 30, so 15% matches up with 30, and then I just have like a question mark here. What would be the whole amount then? So that would be 15% of what amount is 30. And when you lay them out side by side, then you can kind of see the relationship of them in that 15%. If you think about 30 is twice 15, then I need to have a 200 here. So just looking at that model, you might be able to reason your way there. There are a lot of other ways to find these percent problems. Like here, I actually drew the proportion, like 15 out of 100, that would represent 15%, is, our equal sign, 30 out of what number is the same as 30 out of what number? And then you could try to create that equivalent fraction here. It'd be kind of the same thing. 15 times 2 is 30. 100 times 2 is 200. So 15% of 200 is 30. I did the same thing for this one, but it might make a little more sense for this one because I filled in all the missing percents along the way. Jane bought a $40 pair of pants. She has a 20% off coupon. How much was the discount for the pair of jeans? So we're trying to figure out how much 20% of 40 is. So on the top of this double number line, I listed all the percents, and I just split it. Instead of just drawing the 20% in like I did up above here, I split this into fifths, and I drew the 20, 40%, 60, 80%, and here's 100%. And then across that on the bottom of our across from that on the bottom of our double number line, my whole amount now is 40. And so I have to think about breaking that 40 into the same fifths to match up with these percents. And again, this one works out nice because 40 divided by 5 is 8. So 20% of 40 is 8. 40% of 40 is 16. 60% of 40 is 24. 80% of 40 is 32. You notice I was just counting by eights there because I was adding 20% each time. So the discount was $8, or thinking of it this way, 20% of 40 is 8. I also drew the little proportion over here, same as before. Another nice trick with percents that are easy to convert to 10% is 10% of any number. We just slide the decimal 1 to the left. For example, 10% of 40 here is $4. I would just move that decimal point 1 to the left to find that 10%, right? Divided by 10, you think of it that way. And so if 10% is $4, 20% is twice that. So 20% of 40 then would be $8. And we can kind of do the same thing even up here. Up here they gave us the percent of the amount is 30, so they didn't give us the whole up there, so that one doesn't work that quite the same way. Down here with number 8, during the season, Jasper scored 14 goals, Sully scored 22 goals, Nelson scored 11 goals, and Tate scored 23 goals. What percent of their total did Jasper score? Well, first we had to add up to find their total, And I did that over here on the left-hand side. I found they scored a total of 70 goals. So we know Jasper scored 14 out of 70 goals. We need to find that percent. So I put 14 of 70 as a fraction, and then I just divided that out. Use my calculator on this one. 14 divided by 70 is 0.2, which is 20%. If it helps to have this 0 on here, we can add that, because we know that that's 20 hundredths, right? And we could even try to come up with that equivalent fraction here for 14 70ths to see how many out of 100 it would be. It would be 20. There isn't a nice easy conversion for us here, but we could reduce this fraction all the way down into simplest form. In this case, it would be 1/5, right? 1/5 you might also just recognize as a benchmark. That's 20%, or you could take the 1/5 and then create the equivalent fraction back up to 20 1/100ths to know that it's 20%. So there's a lot of different ways to think through that one.